The story of airplanes begins with humanity's enduring dream to fly, a fascination that dates back to ancient times. For centuries, people have strived to conquer the sky, inspired by birds and their ability to soar through the air. Although the dream of flight remained just that for a long time, several key events contributed to the development of airplanes as we know them today. Early concepts, ancient cultures, such as the Greeks and Chinese, have records of individuals experimenting with flying contraptions, often inspired by birds. Examples include Greek mythology with Icarus and Daedalus, and the Chinese inventor Wan Hu, who, according to legend, attempted to fly himself using rockets in the 16th century. Hot air balloons. In the 18th century, the invention of the hot air balloon by the Montgolfier brothers revolutionized aviation. The first manned flight took place in 1783, and although it wasn't an airplane in the modern sense, it laid the groundwork for understanding air pressure and the possibility of air travel. The Wright brothers, Orville and Wilbur Wright, are often credited as the pioneers of modern aviation. In 1903, they succeeded in conducting the first controlled, powered flight with their aircraft, the Wright Flyer, in Kitty Hawk, North Carolina. They utilized a combination of aerodynamic principles, engine power, and control mechanisms to keep their airplane airborne. Technological advancements. Following the groundbreaking flight of the Wright brothers, technological advancements accelerated the evolution of airplanes. World War I served as a catalyst for aircraft innovations, with improvements in engine technology, materials, and aerodynamics leading to better and more powerful airplanes. Further developments. After the war, aviation became a commercial industry. Aircraft designs became more sophisticated, flying farther and higher. The introduction of jet engines in the 1940s and 50s again transformed aviation, making airplanes faster and more efficient. Since then, aviation has continued to evolve. Modern airplanes are the result of ongoing technological advancements, from advanced materials to computer systems that control flight. This evolution has led to various types of aircraft, from commercial passenger planes to military jets, helicopters, drones, and experimental airplanes that continue to push the boundaries of speed and altitude. The construction of modern airplanes involves a complex and precise process that integrates advanced engineering, materials, and technology. Here's an overview of the construction process. Design phase. Engineers and designers start by creating detailed plans and blueprints for the aircraft. This phase involves aerodynamic studies, structural analysis, and the integration of various systems. Material selection. Modern airplanes use a combination of lightweight yet strong materials. Aluminum alloys, titanium, carbon fiber composites, and advanced polymers are commonly used for different parts of the aircraft. Each material is chosen based on its strength-to-weight ratio, durability, and specific application. Airframe construction. The airframe, or the structure of the airplane, is built using a combination of metal and composite materials. Fuselage sections, wings, tail sections, and other components are manufactured separately and then assembled. Fuselage. The main body of the aircraft is constructed using a series of frames, stringers, and skin panels. These are assembled to create the fuselage's shape and structure. Wings. Wings are typically made of aluminum or composite materials. They consist of ribs, spars, and skin panels that provide the necessary aerodynamic shape and structural strength. Tail sections. The tail of the aircraft includes the horizontal stabilizer, vertical fin, and rudder, providing stability and control. These sections are constructed similarly to the fuselage and wings. Engine installation. The engines are mounted onto the wings or fuselage depending on the aircraft's design. Aircraft engines, whether turbofan, turboprop, or jet engines, are meticulously installed and connected to the aircraft systems. Avionics and systems integration, avionics, which encompass the aircraft's electronic systems and instruments, are installed and integrated into the aircraft. This includes navigation systems, flight control systems, communication equipment, and more. Wiring and connectors are meticulously installed to ensure proper functionality. Testing and quality assurance. Once assembled, the aircraft undergoes rigorous testing, including structural integrity tests, engine tests, and systems checks. These tests ensure that the airplane meets safety and performance standards. Certification and delivery. After successful testing and approval by aviation authorities, the aircraft is certified for operation. It is then delivered to the customer or operator. Throughout this process, precision engineering, attention to detail, and adherence to strict safety standards are crucial. Modern airplanes require a highly skilled workforce and advanced manufacturing techniques to produce high-performance, safe,